Good morning, everyone. This is Majidur Islam, ID 2240815. Today, I want to discuss about language model neural network. Language model RNN are designed for a sequential data, where the order of information matters. In this presentation, I will discuss how sequential modeling is needed, how standard RNN work, how it is learned through backpropagation, time, and the main carrier-related limitation and standard of RNN. Before understand RNN, we need to understand the limitation of feed-forward neural network. Feed-forward neural network generally work with fixed size input and do not naturally maintain temporal memory. However, real-world sequence such as text, space and time series data can have different length and depend on strongly on previous information. Sequential context is important because the meaning of the information often depends on what comes before it. The natural language changing the word can change the meaning of the entire sentence. Traditional approach that ignore order can lose this context. RNN maintain hidden memory state that is updated at every step. An RNN process sequence one step at a time. We can think of this previous memory plus current information, produce new memory. The hidden state acts as an impact representation of the information the network has seen so far. This slide shows the standard RNN architecture at as time step we have the input, hidden state, and output. The hidden state depends on both the current input and the previous hidden state. An important feature is that the same weight matrix and reuse at every time, every step. Propagation through time. There are two types of propagation: forward pass loss competition and backward gradient accumulation. The sequences process forward to compute output prediction and individual cross entropy loss term at its time step. Backpropagation gradient accumulation, gradient of the total loss with respect to shared weight accumulate contribute backward across all steps. Limitation limitation of standard RNN. Gradient are repeatedly propagate through many time steps. This can create two major problems: vanishing gradient and explode gradient. When gradient become very small early and step receive almost no useful learning signal. When they become extremely large, training can become unstable. Gradient clipping is a commonly used to control exploding gradient. Case study: character level LLM. Character level text generation. Early RNN language model operate at the character level, learning vocabulary, syntax, and spelling from raw text stream. Input encoding: one word vector for character input at step T. Predicted objective model output and probability distribution over the entire alphabet for the character T plus 1. Auto regressive generation: simply character at the fit iteratively back into the next step. Case study: sequence to sequence architecture. The process input sequence into single fixed length context. RNN have been used for applications such as character level text generation and sequence to sequence model. In character level language model, the network process one character at a time and predict the next character. In sequence to sequence character architecture, an encoder process the input sequence, and decoder process the input sequence, and decoder generate the target sequence step by step. This idea was especially important in early neural language and translation system. That's all. This is my image source that I am used uh, over the presentations. Thank you everyone.